let's explore inverse functions. We will say that two functions are inverses of each other if they are reflections of each other. Let's write down what this precisely means. It means two things. First, if I take any element x in the domain of G, I have x, I can apply G to x. We want f to reflect g of x back to x. F of g of x equals x. And on the other hand, if I take any element x in the domain of f, I then have f of x. We want g to reflect f of x back to x. So if these two conditions hold at the same time, we say that f and g are inverses of each other. So what happens for two functions that are inverses of each other? For one thing, if I take an x in the domain of G, this top line, g of x is in the domain of f. And if I take any x in the domain of f, you look at the second line, f of x is in the domain of G, because I can form g of f of x. So we always have this picture. And in fact, the range of f will be all of the domain of G, and the range of G will be all of the domain of f. These follow from these two conditions. Another important consequence is that f and also g must be 1-to-1. Let's see why f must be 1-to-1. Suppose two inputs, possibly equal, have the same output. We want to actually prove that they are equal, in fact. They go to the same y. What about g of y? Again, y is f of x1, and y is f of x2. So now g of f of x1 is x1. And g of f of x2 is x2. Remember these conditions. So we have this and this. Since g is a function, g of y can be only one thing. So x1 equals x2. So f is 1-to-1. And the same for g. In this situation, what can we say about g? What, if anything, do we know about g of x? Well, g of x is defined. It's some element y in the domain of f. What do we know about y? Well, since f and g are inverses of each other, we know that that is x. So we know that f of y equals x. And f is 1 to 1, so y is the only input whose output is x. So when a function has an inverse, the inverse is unique. In other words, it either has no inverse or exactly one inverse. When it does have an inverse, we denote it by f to the minus 1, f inverse. And it's given by the rule, if f of x equals y, then f inverse of y is that unique element x whose output is y. Every function that is 1 to 1 always has an inverse. So the functions that have inverses are precisely the functions that are 1 to 1. So we have this picture. And I'd like to find an inverse. What would this be? Well, x is in the range of f. So there's an element y in the domain of f with f of y equal to x. And since f is 1 to 1, there can't be more than 2 inputs with output x. So we'll define f of f inverse of x to be y. And we can check that f and f inverse, this function f inverse, are inverses of each other. Let's summarize. And in this case, f inverse of x equals y, where f of y equals x.